Biodiversity is one of the most important component of the biological nature of our planet Earth. It is the variety and variability of life on Earth. It can be measured on various levels. There is, for example, genetic variability, species diversity, ecosystem diversity, and phylogenetic diversity. Diversity is not just distributed evenly on Earth, it is greater in the tropics as a result of the warm climate and high primary productivity in the region near the equator. Tropical forest ecosystems cover less than one-fifth of the Earth's terrestrial area and contain about 50% of the world's species. There are latitudinal gradients in the species diversity for both marine and terrestrial taxa. Since life began on Earth, six major mass extinctions and several minor events have led to the large and sudden drops in biodiversity. The Phaneroic Aeon make a rapidly growth in biodiversity via the Cambrian explosion. In this period, the majority of multicellular phyla first appeared. The next 400 million years included repeated massive biodiversity losses. Those events have been classified as mass extinction. In the Carboniferous rainforest collapse may have led to a great loss of plant and animal life. The Permian-Triassic extinction event 250 million years ago was the worst. Vertebrate recovery took 30 million years. Human activities have led to an ongoing biodiversity loss and an accompanying loss of genetic diversity. These processes often referred to as Holocene extinction or sixth mass extinction. For example, it was estimated in 2007 that up to 30% of all species will be extinct by 2050. Destroying habitats for farming is a key reason why biodiversity is decreasing today. Climate change also plays a role. These can be seen, for example, in the effects of climate change on biomes. The anthropogenic extinction may have started toward the end of Pleistocene, as some studies suggest that the megafaunal extinction event that took place around the end of the last ice age partly resulted from overhunting. Biologists most often define biodiversity as the totality of genes, species, and ecosystem of a region. An advantage of this definition is that it presents a unified view of the traditional types of biological variety that have been previously identified. Taxonomic diversity, usually measured at the species diversity level. Ecological diversity, often viewed from the perspectives of ecosystem diversity. Morphological diversity, which stems from the genetic diversity and molecular diversity. Functional diversity, which is a measure of the number of functionally disparate species within a population. Example, different feeding mechanism, different motility, predator versus prey, and other related phenomena. Diversity is most commonly used to replace the most clearly defined and long established terms species diversity and species richness. However, there is no concrete definition for biodiversity, as its definition continues to be defined and redefined over time. An explicit definition consistent with its interpretation was first given in a paper by Bruce A. Wilcox, commissioned by the International Union for the Conservation of Nature and Natural Resources (IUCN) for the 1982 World National Parks Conference. Wilcox's definition was: biological diversity is the variety of life forms at all levels of biological systems that use molecular, organismic, population, species, and ecosystem. A publication by Wilcox in 1984 highlighted biodiversity as a phenomenon that can be defined genetically as the diversity of alleles, genes, and organisms. They study processes such as mutation and gene transfer that drive evolution. The 1992 United Nations Earth Summit defined biological diversity as the variability among living organisms from all sources, including inter alia terrestrial, marine, and other aquatic ecosystems, and the ecological complexes of which they are a part of, which includes diversity within species, between species, and of ecosystem. This definition is still used in the United Nations Convention on Biological Diversity. Gaston and Spicer's definition in their book Biodiversity and Introduction in 2004 is a variation of all life at all levels of biological organization. However, the Food and Agricultural Organization (FAO) defined biodiversity in 2019 as the variability that exists among living organisms, both within and between species and the ecosystems in which they occur. It is important to conserve biological diversity. Conservation biology matured in the mid 20th century as ecologists, naturalists, and other scientists began to research and address issues pertaining to global biodiversity decline. The conservation ethic advocates management of natural resources for the purpose of sustaining biodiversity in species, ecosystem, the evolutionary process, and human cultures and society. Conservation biology is reforming around strategic plans to protect biodiversity. Preserving global biodiversity is a priority in strategic conservation plans that are designed to engage public policy and concerns affecting local, regional, and global scales of communities, ecosystems, and cultures. Action plans identify ways of sustaining human well being, employing natural capital, market capital, and ecosystem services. In the EU Directive 1999/22/EC, zoos are described as having a role in the preservation of biodiversity of wildlife animals by conducting research or participation in breeding programs. Removal of exotic species will allow the species that they have negatively impacted to recover their ecological niches. Exotic species that have become pests can be identified taxonomically, and their removal is very important to help in the thrive of the local biodiversity. As sustainable populations of the remaining native species in an area become assured, missing species that are candidates for reintroduction can be identified using databases such as Encyclopedia of Life and Global Biodiversity Information Facility. Biodiversity banking places a monetary value on biodiversity. One example is the Australian Native Vegetation Management Framework. Gene banks are collections of specimens and genetic material. Some banks intend to reintroduce bank species to the ecosystem. Reduction and better targeting of pesticides allow more species to survive in agricultural and urbanized areas. Location-specific approaches may be less useful for protecting migratory species. One such approach is to create wildlife corridors that corresponds to animals' movement. National and other boundaries can, however, complicate the process of biodiversity conservation. It is important that whether in protected areas, national parks, and wildlife sanctuaries, biodiversity of the locality or that particular region is given a prior prominence so that they can be protected and preserved by humans to the best of their ability to have something left for our future generations. The anthropogenic activities around the world, climate change, global warming, sea level rise, and various other natural and anthropogenic phenomena are impacting biodiversity at a global scale. It is important, therefore, to include all measures possible at international, regional, and local scales to include strategies in the form of in situ and ex situ conservation to help protect biodiversity conservation. Without biodiversity, our planet runs critical danger of becoming extinct. Shoikat Kumar Basu.